Hello and welcome. We were discussing the properties of alkyl halides, which are very important compounds for synthesizing many other organic compounds. That is, the Chauraha, from where we can go to different places, to Jagatpur, to Bhadrak, to supposing Jagatpur Square. You go to Bhadrak, Baleshwar, Baripada in one route, and Salepur, Kendrapada in another route, and come back to Cuttack in another route. So there are several. Just like that, alkyl halides are very good substrates for nucleophilic substitution, particularly, as well as elimination. Yesterday last class we talked about if we take 3-degree halides and we take strong bases, any strong base which is a conjugate of a weak acid, strong bases like OH minus, CN minus, alkoxide ion, alkynide ion, alkyl carbanion, all these strong base, amide ion, these will never ever go for substitution with 3-degree halides. And in 2-degree halides, they will give the major product as substitution, maybe 60 or 70%, and maybe 20, 30 or 40% will be substitution. But 1 degree, the major product will be substitution with strong bases. But if you are using a weak base, carrying out solvolysis process, which will go via the SN1 route, because the weak bases are not good nucleophiles, so they will prefer breaking down the CX bond first to form the carbocation, that is the SN1 track. We shall be discussing in details today. And so that is 3-degree will be reacting fastest. Will give good yield of the product. The solvolysis product. In hydrolysis, you get alcohol. In alcoholysis, you get ether, and so on. So we shall be today. We have taken how many nucleophiles? Yes, 6. So we'll be starting today with another page, SN reaction of alkyl halides or haloalkanes. So this is 7 with cyanide ion that will be given in the form of KCN, NaCN. Well, alcoholic medium is a general necessity. Good morning, Saminani. Good morning.
Good morning.
Alcoholic solution is necessary. So don't be so much biased or swayed away by the term alcoholic for your competitive tests. If alcoholic KCN, cyanide ion, will bring about elimination in 3-degree halides and substitution in 1-degree halides. What about alcoholic KOH? Why alcoholic KOH will bring about elimination in 1-degree halides? That's a fantastic, a proposition. So that what happens, this cyanide ion is the real nucleophile, which will give you, as you know, alkyl cyanide, or you can, in IUPAC, it is alkane nitrile. Of course, 1 degree is greater than 2 degrees, greater than 3 degree halides. That is understood. That is a general principle, Samida, that whenever you are handling an alkyl halide, and that too it is a 1 degree, and your nucleophile is a strong base, cyanide ion being the conjugate of a weak acid, HCN, then it will be the major product. I mean, the exclusive product will be substitution. But instead, if you are taking a 3 degree halide, you expect nearly 100% product to be elimination. The major product will be elimination. Yes, if you make the solvent more polar, alcohol instead of alcohol, you take water, then maybe 10%, 5% some substitution product might be there. Even then, the major product will be elimination. 2 degree halides behave like 3 degree halides, but it's not exclusive product. Elimination is not the exclusive product like 3 degree. You get a mixture of substitution and elimination. Elimination still is the favored product. Must remember that. And alcoholic medium is an absolute necessity for organic reactions. So in aqueous medium, you can't do it. If you prepare the substrate solution in alcohol, then you are writing aqueous KOH, aqueous KC, and it carries little meaning. It will be mostly alcoholic. A little bit of water is added with the reagent KCN or whatever to increase the polarity, the net polarity of the medium. Now, uh, supposing I will say, I'll give like this. Your first job is to see that it is not substitution that you think of, it is elimination. But yes, if I am giving a 1 degree halide, even if it is isobutyl, yes, because uh, then it will give a major product of this. This is SN2 and this is E2. We shall be discussing as we continue more and more in this chapter. Will be clear about the mechanisms U1, E2, U1, CB, SYN, and other mechanisms of elimination, and SN1, SN2, SNI. I have told you, just sounded about SNI. Can you remind me, Rudra, where SNI mechanism occurs and what is the stereochemical consequence?
Sir, thionyl chloride.
Yes, alkyl halide with a chiral center, particularly secondary halides, and we shall only take the substitution product, not the elimination. The elimination I have told you will be the major one. But there is a twist and turn in 2 degree. In 2 degree, we can manipulate. Supposing instead of taking a strong base, we take a solvolysis reaction. We want alcohol. We will not take aqueous KOH or alcoholic KOH. You take water, simply water, solvolysis. In that case, 3 degrees greater than 2 degree, greater than 1 degree. So in that case, you can uh, absolutely tilt the mechanism in favor of SN1 and hence the substitution product. On the other hand, if you take a strong base with acetone as a solvent, which is an aprotic solvent, maybe polar, doesn't matter. Aprotic solvent, it will not favor the formation of carbocation. It will favor 100% SN2. So, if you want SN1 for 3 degree and 2 degree, then we have limited choice. We have to think of solvolysis using a weak base. That is the moot point. But yeah, if you only think of the substitution product and you are using thionyl chloride SOCl2 with alcohol, I am so sorry. It's not alkyl halide. It is the preparation of alkyl chloride. We had discussed in the preparation. I went in a wrong way. Alcohol, if you are taking a 2-degree alcohol, there is a chiral center like butan 2-ol where we can see the configuration inverted or racemization or retention. You take an absolute pure R or S butan 2-ol and use thionyl chloride, you will find the same R or same S without change in configuration. That is the beauty of thionyl chloride, where I unnecessarily spoiled time by talking about the properties of alkyl halide, which we are continuing. But here it is preparation. Yes, you have rightly reminded, with thionyl chloride, you will definitely get. We will talk about the mechanism, how it is happening, why PCl5, PCl3, all these are going for SN2 with inversion of configuration with alcohols. Why not SOCl2? What is the difference in the mechanism? We shall see. Then the other one, we can have, we have seen Williamson synthesis of ether. This is now cyanide. We can have the salt of carboxylic acid with salt, a ionic salt like sodium potassium salt. Formation of, ester. This is another way where carboxylate ion, alkanoate ion is relatively a strong base. Relatively, because its acid, carboxylic acids are weak in general, so they are strong, but not as strong as cyanide ion or amide ion or hydroxide ion. So when you take an alkyl halide, here also you have, let us make it R dash, CO minus is the nucleophile, so that it will favor SN2 because it is a strong base. But if there is water, and since it is a bulky one, the rear attack is a little difficult, so you get a mixed mechanism. Therefore, I am not writing. So you will get, no doubt, the major product will be this one. So this R will be the a part of the alkyl group. I mean, this is what we call alkoxy, but actually the name is alkyl alkanoate. This oate contains the second O. So this is bound to be 1 degree greater than 2 degree greater than 3 degree because it is a strong base. But often we do not take alkanoate this for carrying out elimination. But you can, supposing you are given a question with a alkanoate ion with a 3-degree halide, then you might consider, should consider, there will be an appreciable percentage of elimination product. We shall be looking to that. So this will be the ester formation. And another one is just it's like a solvolysis reaction. You are using simply alcohol, and the lone pair on oxygen will be the nucleophile. Since it is a weak base too. It is an acid. So as a base, it is a weak base. So only it has got polarity. I'm not talking as an acid, as a base. It is a weak base. So it's like a solvolysis reaction where you SN1 process will be favored. So you get the same thing, R O C double bond O R dash plus HX. So same ester, but here the 3 degree will be taking the lead because that will form the carbocation most elegantly. So that is, and the other one is the alkynide ion. So if you have an alkynide ion like sodium alkynide with any alkynide ion, alkynide ion can only be prepared if there is a acidic hydrogen. A terminal alkyne can give alkynide ion. An internal alkyne can never ever give the salt. So if you have an alkynide ion, which is a strong base, so you have an alkyl halide, same principle will apply. So I'm just writing as such without looking at the mechanism. This supposing this is R dash. So this is RC double bond C and R. You get a higher alkyne plus NaX. And here also 1 degree is greater than 2 degree and greater than 3 degree. Because if you take 3 degree, then the major product unfortunately will be elimination. So we'll not waste time. We'll look for more nucleophiles which carries out nucleophilic yeah. But here you should take pyridine. Whenever there is not here, here. Whenever there is an elimination of ultimately HX, H plus ion, that will be removed easily by using an organic aromatic base, pyridine, to eat away the HCl or HX, HBr, so that the equilibrium will be driven to the right. Whenever there is a formation of H plus ion in any substitution reaction, we use the solvent pyridine, which act as a base to remove, is a weak base to remove the H plus ion. Then we have another interesting nucleophile, that is silver cyanide. Silver cyanide, since formation of isocyanide. But why? Because this is a covalent compound. So when you take an alkyl halide with AgCN, it is a covalent compound. So the nucleophile, I'm sorry, the nucleophile is this. So then in the second step, silver plus goes. So it forms RNC plus AgX. So this is alkyl isocyanide. So if you want isocyanide, use silver cyanide. Because it is a covalent bond, so carbon lone pair is not there. Nitrogen lone pair will take the lead first. Ultimately, in the second step, Ag plus will go away, make the neutral uh, isocyanide. The other one, the 11th one, I guess, this is 12th one. is with yeah, with silver nitride. Unlike silver nitride, silver cyanide, silver nitride is having little more ionic character. So here the nitroalkane, the nitrogen attacking will be more pronounced. So if you want nitroalkane as the major product, then you take silver nitride. So here nitrogen being more basic than oxygen, and that will be the nucleophile, and you get RNO2 plus, of course, minor product will be RONO. This is called alkyl nitrite. This is nitrogen is directly bonded to carbon, nitroalkane, and this is the major product. The other one is the minor product. But if you want alkyl nitrite as the major product, we have to take more ionic compound. This is not a very ionic compound. Covalent character is appreciable, but potassium nitrite or sodium nitrite is 100% ionic. In that case, the ionite ion is free. And the probability of, there is a resonance structure, and so oxygen gets the dominance to attack because of some covalent character in silver nitride and more basic character of nitrogen compared to oxygen. Oxygen becomes the second attacking species. Nitrogen is the primary attacking species, but here oxygen takes the role. So if you take sodium nitrite, then remember that alkyl nitrite is the exclusive product, is the major product. So I'm not writing the other one. And you can leave little bit of space to add some more nucleophiles if required. Then we go to the second type of reaction, that is elimination. When we say elimination, it is beta elimination. So as you already know from alkenes, that whenever you take an alkyl halide Rx with a strong base, for example, OH minus, OR minus, or these are or NH2 minus, or alkynide ion, or cyanide ion, etc. Then, and this is a 3-degree halide, the absolute product, and you take alcohol as the medium, don't put then 100% elimination product you get. 2-degree, you get a mixture of both. Now, if we talk about that, only talk about elimination, and let me tell you that supposing we have this one, you are familiar with the term alcoholic KOH. Let us take that. But you can take alcoholic sodium ethoxide, alcoholic sodamide, alcoholic sodium acetylide or sodium propionide. alcoholic sodium cyanide or potassium cyanide, the result will be same. Substitution product will be minor. I'm taking secondary. Had I taken tertiary, then it would have given 100% elimination product. You might be wondering how. A 3 degree is a very prone to carbocation formation, and once carbocation is formed, it will just be attached with the nucleophile and give substitution product. But interestingly, carbocation is not formed even if it is a 3 degree halide with a strong base, particularly when you are using an alcoholic medium. Strong base will have a ninefold probability factor more to abstract a beta hydrogen. Now, see what happens here. The beta elimination mechanism I had already sounded you during my alkenes program in class 11. But today, where is my? Yes. Now, what happens? This is beta, this is also beta. So there will be two products. Always it is regio selective. Unlike the addition ADE, which is regio specific, following the Markovnikov rule, particularly when there is a unequal number of hydrogen atoms on the two carbon atoms connecting the pi bond. So that, or if there is a substitution in the adjacent position, there is a hydride shift and we get a rearranged product. That is, okay, that is regio specific. But here, elimination is slow. You have to heat it. Heat is absolutely required. And therefore, you get both the products 80-20. The measured product will be the more substituted product. The thermodynamically stable product will be the measured product. It will be driven thermodynamically, not kinetic product. Well, here there is no competition between kinetically controlled reaction and thermodynamically controlled reaction. Thermodynamics here is the only way to decide. There are cases where kinetics takes the lead. Thermodynamics is subsided and it gives way to kinetics. I will discuss those cases where kinetics, though thermodynamically measured product would have been different, but kinetics now drives the mechanism in its favor. So ultimately, the kinetically driven control product becomes the measured product. But this is not the case. Now here, this will come here. The base will abstract a beta position. This is with respect to halide. It is alpha, this is beta, and this pi bond will form, this will go. Now I have told you that the stereoelectronic requirement for when elimination will occur, particularly the E2, here E2 will happen, that the two leaving groups should remain anti. The anti-periplanarity is the stereoelectronic requirement for E2 beta elimination. But E1, just like SN1, first the CX bond will break and you get a positive charge. And then the beta proton will go in the second step, which is not contributing to the rate law. But remember, in alkyl halide, if you are getting a measure product, elimination as the measure product, you can never ever have E1 mechanism. E1 mechanism comes into force during solvolysis when you are taking a 3 degree halide and you are using water, alcohol, acetic or carboxylic acid. You are carrying out a solvolysis program and you expect a measure product, 80% product as the substitution product, and 10-20% will be the elimination product. That will be in E1. This will be SN1 and that will be in E1. Because carbocation has already been formed, you do not have a strong base which will take the precedence of attacking the beta hydrogen. Instead, the polar solvent will favor the heterolytic cleavage of the CX bond and form the carbocations. And once the carbocation is formed, the major product will be substitution, no doubt. But even if water is a weak base, it will also have some, because it's present in large excess, it will have some role to devour the beta hydrogen. And because you are heating, if you are heating, then it will also undertake beta elimination to smaller extent, 10-20%, and give the elimination product. And that mechanism is SN1. And the probability factor is, if it is third butyl or third butyl halide, then 3 plus 3 plus 3, 9 beta hydrogens. The probability factor of abstracting one beta hydrogen atom out of 9 will be 9 times greater. And it's a strong base having a good basic property. So it will not show its nucleophilicity, although strong bases are good nucleophiles, only when a carbocation is formed. So even if 3-degree carbocation is extremely stable, but it will not favor because you are using alcoholic medium deliberately. And if you use aqueous medium is more polar, then there will be some percentage of substitution, not much. Still, there is a dominance of uh, elimination product, right? So, what I was saying, you will get two products, as I remind you that the Sajef rule, this is one, and this is the major one. And because it is more substituted, more number of hyperconjugation structures, and hence more stability. And the minor product will be this one. I'm showing in a different ink. You guys are, in other molecules, not in the same molecule. So you get, this is minor, and we know it's Sajef. This is Sajef's rule or elimination. Hyperconjugation is the reason for which we have the Sajef rule coming into force. So goes without saying that if you are taking a 3-degree halide, and supposing instead of using alcoholic KOH, I'll be giving you this one. Alcoholic sodium ethionide or acetylide. So what will be the product? In the an average thinking student will be going for a substitution, will be doing like this. And he will think of a higher alkyne, an alkyne, formation of alkyne. But now, its job is to carry out beta elimination. It is a 3-degree halide. 9 times there is beta hydrogen. So anyone will do. So let me show here. So the only product that you get is this. Plus, of course, this will become another organic product. Acetylene will be the byproduct in this. And of course, Na plus Cl minus. But this substrate that you took, that is alkyl halide, is converted to alkene. Forget about what is the fate of the base that you have chosen. Here I say it is base. But the same alkynide ion, as supposing I will be taking ethyl bromide or any other 1-degree halide and do the same thing. So here it will be substitution and the major product will be the alkyne. plus Na plus. This is SN2 and this is E2. We'll talk about the detailed mechanism later. But if you want anti-Sajef elimination, and not only that, elimination in 1 degree halide as measure product. Supposing you have N-butyl chloride and you want that you get one butene. There is no question of getting two but 2 in. You will be getting but 1 in, only one but 1 in. It's not like alcohol that you will protonate it and it will go as water, carbocation rearrangement will happen. Such a thing will not happen with halides. Now, the only thing that you can do, you can use a very bulky but strong. Bulky but strong. Bulky and strong base. Like potassium or sodium tert butoxide ion. TBUO minus. TBUO minus tert butoxide. And so it is so hefty, so bulky that it cannot enter into the beta position to abstract, no, so it cannot enter the Chhatri. Even if it is 1 degree, this is so bulky that it cannot enter into the umbrella, the inner side of the umbrella for SN to attack. Rather, it will be removing a beta proton from the periphery. Protons are in the periphery and it is not going to attack deep into the cavity of the carbon and attaching with carbon, but it is just abstracting a beta proton from periphery so that it will undertake, and the major product will be not only in this case this major product, and that is undoubtedly E2, but this is anti-Sajjay product will be formed. Of course, here there is no meaning of anti-Sajjay. If you take but, sec-butyl bromide, in that case you are using TBO minus and K plus. So the major product will be this. Not only it will be favoring elimination because it is a strong base by nature. We are now using 2 degree. Sone pe suhaga. 2 degree is more prone for elimination than 1 degree. So we have converted to 2 degree. That's okay. Elimination will be the major product. And here the but 2 in will be the minor product. Of course, that will happen. This is the major one. The anti-Sajjay product. Of course, there is some minor product thermodynamically. This is what we call the kinetically driven product. Although thermodynamically but 2 in is more stable than this, but we don't get this is minor because the bulk of the base will not allow the reaction to happen at a reasonably faster rate. The faster rate will be the abstraction of the proton from the less hindered position. This is the less hindered position. This is the more hindered position. So we are talking only about elimination, not talking anything about substitution. Substitution will be the minor. But amongst the elimination product, the Anti-Sajjef elimination product will be the major. The other Sajjef elimination will be the minor, and still minor will be the, I mean, may not be still minor, maybe as much minor as the Sajjef product will be the substitution product. 2 degree, there will be some amount of substitution product, but that will be minor. The major product will be the elimination, and that too anti-Sajjef, because the base is bulky to enter into a more hindered position for same abstraction of beta hydroxyl. Are you following, Samida?
Yes, sir.
Hmm?
Yes, sir.
I am not hearing so. Are you following Master Aryan,
Yes.
Rudrani? Sorry, Rudra.
Yes, sir.
Well, we are almost at the end of the program. Then we will be going for the detailed. So, what is the conclusion? Conclusion, as we find, because we had studied substitution, we have studied elimination, and we know that if you are using a 3-degree halide, you are using a strong base. I will not write down the names, so I have written so many times. The E2 elimination, that to E2 elimination is the major product. Elimination is the major product. It may be absolute product if you are using an alcoholic medium. And if you are using 3-degree halide, same 3-degree halide with a weak base, like water, like alcohol, like carboxylic acid, these are weak bases. As base, I'm talking of, not as acid. So this will be the substitution, will be the major product. Of course, there will be some amount of elimination, major huch eta, and that too SN1 mechanism. Of course, we can't rule out the minor product. Elimination product will be minor, and that is E1. I will talk about the details later. And in contrast, if you take 1-degree halide, I'm not taking 2-degree now. 2-degree I'll take after. And you are using a strong base. The major product is substitution, and that to SN2. Major. There might be some minor product, 10-20% elimination. That is by definitely E2, because strong bases here will act as strong nucleophiles. Because substitution means nucleophile. Strong bases are usually strong nucleophiles. Of course, weak base can be a strong nucleophile down the group. We shall study that later. So, and if you want elimination in 1-degree halide, then you have to just choose bulky strong base like TBO minus K plus. You get elimination as the major product. And sometimes anti-Sajjef. When you are taking, of course, if you are taking 1-degree, anti-Sajjef question doesn't arise because it is in the terminal position. So there is no question of anti-Sajjef. But if it is 2-degree, there can be anti-Sajjef. You are using a 2-degree halide with a strong base, and I have given the example alcoholic medium. So there will be both products appreciable. Still, elimination is the major product, and that to E2 major, and substitution SN2, because strong base is a strong nucleophile 2, is the minor product. It's not 100%, but still major. Later on, we shall see that if you are using a 2-degree halide with a strong nucleophile, but weak base, like we shall study that RS minus, or you have S2S, or you have PS3, etc. down the group. They are more polarizable because of a larger size of sulfur and phosphorus. So they have a more at their weak basis. But as a nucleophile, they are strong. The attacking power is more. So the major product will be the substitution. But they are strong nucleophiles. We'll be talking about that sulfur, phosphorus, and um, halides down the group. All this. These are soft bases, though weak. So major product is substitution. Minor product will be elimination. Just the opposite. Strong nucleophile but weak bases. Example is this. You can have S2S also. So with this, we conclude not today's session. We'll be discussing uh, let's I give you some thing to do. All you guys write only the major product.
Yes, sir.
मैं पागल हटा सॉरी नहीं ये सर को लड़ने से So done? So today um, we will see if we are left with three things. Two things. I think we are left with mechanisms, all substitution mechanisms and elimination mechanisms. That is most important. After that, we'll go for haloarenes, chlorobenzene, where we will be also learning the aromatic nucleophilic substitution. Here, we are talking of SN means it is aliphatic, not related to chlorobenzene. Chlorobenzene, the mechanism is something different, although it's nucleophilic, but its the mechanism is completely different. We also see a different mechanism in chlorobenzene involving benzyne intermediate, the sine substitution mechanism, CINE, the name of a scientist, sine, which is the mechanism when there is no supporting minus R groups in the orthopara positions. Hegela. This is butyl chloride.
Yes, sir.
अच्छा एटा कौन हला कुह
सर एटा होची सोडियम सर सी
sodium salt, simply
यस सर
the
सोडियम
sodium salt. Yeah,
यस यस सर
this is because acetylene pai you can take sodium, only sodium नहीं पारिबो liquid ammonia रे किंतु other terminal alkynes pai sodamide is better. Here amide ion is the base, not sodium is the base. So what happens, you will get the corresponding sodium ରହିବ ଯିବ କୁଆଡ଼େ sodium propionide. And if you go in this direction C, then since it is a strong base and this is a 1 degree halide, so the major product will be substitution.
यस सर
ଏଇଆ ହେଇଛି
यस सर
this is pent to wine. ठीक है
यस सर
and the mechanism କହିଲ ଦେଖିବା SN1 or SN2 ମୁଁ ଯେତିକି କହିଲିଣି ବାରମ୍ବାର କହି କହି ହେଉଛି କ'ଣ anyone
SN2
precisely strong bases are also strong nucleophiles, particularly the first period strong bases, the alkynide, the carbanion, amide ion, OH minus, NS2 minus, these are all strong bases. So strong bases are strong nucleophiles. So, and it is 1 degree, chhatta is free, there are 2 hydrogen. So the rear attack, we shall be studying in details. Now this is SN2 and this is, and what will be the D?
सर अल्किन
Which alkene?
मतलब सर
Z or E?
सर
अरे
सर सिस
ସେଇଆ କହୁନ, cis କ'ଣ Z କହୁନ? Yeah, had it been sodium in liquid ammonia, then it would have been trans. But if it is hydrogen with Lindlar's catalyst poisoned by quinoline, you get the cis product. এটা বোধ ହେଇନଥିଲା ରୁଦ୍ର এটা বোধ
नहीं
କରିଥିଲ
सर यस सर
it will get the cis or Z product, Z alkene, Z pent tween. This will be controlled hydrogenation using the Lindlet's catalyst. Now coming to this, in this direction, what will happen? What is B?
Sir, alkene.
Alkene, because a 3-degree halide and a strong base, so the major product from the substrate, of course, same amount of propine will be formed, but I am not interested in that, although it is one of the byproducts. But we are looking for the product formed from this substrate. This is substrate. This is a reagent because it's ion. So it will be isobutylene or isobutene. I'm not showing you how E2, this is E2 elimination will occur because there are 9 beta hydrogen atoms, a strong base that will abstract a beta proton and favor E2 mechanism in nearly 100%. And then this is an unsymmetrical alkene, but no room for rearrangement. So this is hydroboration, oxidation. It will give you what?
Sir, alcohol.
Which alcohol?
Sir, primary, মানে antimarconic.
Yes, isobutyl alcohol. No,
Yes, sir.
isobutyl alcohol. The antimarconic of alcohol is formed ultimately, but in 2 steps.
Yes, sir.
And of course, we already know that the stereo factor, the addition mechanism is syn. Had there been any chance of getting chiral centers, then you would have accordingly both HOH coming both from the top, both from the bottom. You could have shown the 2 enantiomers. You understood?
Yes, sir.
Depending on which alkene it is giving, as seen, sorry, Z alkene or E alkene. But here there is no such thing. And what about this? This is the Kharas or the peroxide effect that will give you the bromine
Primary
here.
halide.
Same isobutyl bromide. Yes or no?
Yes, sir.
And this will be simply what? What is F?
Tertiary alcohol.
Alcohol, because there is no room. Had there been some other, here, no, here there will be no question of any rearrangement because 3-degree carbocation is formed. Whenever there is a 1-degree or 2-degree carbocation and there is a adjacent hydride shift or alkyl shift, then you get a rearranged product. So here there will be no other competition. So you get 3-degree alcohol. So ठीक ଅଛି?
Yes, sir.
You got it, Samidha?
Yes, sir.
Now, one more I will give you. Uh, of course, I cannot make it longer. Deliberately, I've taken a 1-degree halide. Uh, oh, we have left one thing. Yes, we'll be doing that. Okay, so এদিকে কলো দেখিও। I have given you 4 nucleophiles. All are SN reaction and that to SN2. 1 degree means SN2. Of course, when you take 1 degree with a weak base, then also, you know, 3 degree is the best choice, but still if you have 1 degree, the reaction will be slow. It will be SN2, no doubt. 1 degree with a weak base like water, we're taking isobutyl chloride with water, then there is a room for hydride ion shift, and the carbocation formation means hydride ion shift. There is a possibility of that. To take only ethyl chloride and you are using water, it will be a slow reaction. And there is no room for alkene formation. Of course, the very minor product will be there if you heat it. But whatever substitution product will come, that will be in SN2. Water is not a good nucleophile, it's a weak base. It will be a slow reaction. There is no room for any rearrangement, and 1 degree carbocation is never formed. It is a hypothetical thing, is never formed. Always goes in one step, either in SN2 one step, or in other cases where there is a side substitution, hydride shift occurs in one step. Higala.
Yes, sir.
So this will be what?
Sir, about CN.
This is propane nitrile
Yes, sir.
or ethyl cyanide. And what about B?
Isocyanide.
It will be isocyanide, NC. And what about C?
Sir, ethyl ether.
Diethyl ether, right?
Yes, sir.
What is that synthesis called? Which son?
Wilkin
Williamson.
Williamson.
Williamson synthesis. And what about D?
Sir, ester.
Because it is still 1 degree and substitution will occur. This will be ethyl acetate. Yes or no?
Yes, sir.
Now, I will give another question. Supposing we want to prepare this ether. You design a Williamson synthesis to prepare the above ether, which you will have to break down into two starting materials. You have two choices. Either you can take tert butyl chloride and bring ethyl alcohol from the market and add sodium metal. You get
Sir,
sodium ethoxide. Or you take tert butyl alcohol from the market, add sodium, bake tert butoxide ion, and take ethyl chloride as the substrate. Which one you will be doing? Rudrani? Choice one. Tell me which is a wrong choice. I am giving you. Williamson means one alkyl halide, one sodium salt of alcohol, sodium alkoxide. Because if you break down from here, make this as alkyl halide and the other one as the sodium salt. This is Williamson synthesis. It looks like the other choice too is you break down here. Make this as alkyl halide, CH3, CH2Cl, and the big one as the alkoxide. Tert butyl alcohol you bring from the market and So which one will give you the desired
Choice
ether?
2.
Choice 1 or choice 2?
The choice 2.
Samita?
Yes, sir. Choice two.
This is absolutely not possible because this will lead to the beta elimination as 3-degree halide. But here, since this is a 1-degree halide, so this will be SN2 mechanism will happen. Of course, you might say that you are talking about bulky base. It will not enter into the umbrella, so it will go for elimination. Uh, well, yes, elimination is a possibility, but uh, I'm talking of the substitution product only. There is a huge possibility that this taught butoxide ion will find difficulty in entering into the umbrella for the SN2. Rather, it will abstract a beta proton from the periphery to give you. I would have given isopropyl here instead of this. I could have given isopropyl. That also will favor elimination to a larger extent. But even then, you measure, even if there will be elimination product, the substitution product will be this one. So this this is absolutely not a route. But yes, in this particular case, bulky base will be definitely favoring elimination of 1 degree. We have studied. If you don't say that, then you are contradicting what you said earlier. Yes, but whatever substitution product will be there, it will be Williamson synthesis, right? So what thing we left, whatever space we left, that a SN reaction, sorry, SN reaction, how many points we had exhausted? 11 or 12? 13. SN, not elimination.
13.
So this one with ammonia, I forgot. Only ammonia. So here, RX, ammonia is a weak base, and but stronger than water. So it has some basicity. It is a base actually. So you get the salt of 1 degree amine. Then you can get RNS2 plus HX. H plus will go away and become a covalent HCl or HBr. If it is non-aqueous medium, then it will be. And then this secondary, the primary amine becomes the nucleophile to attack another this thing. So you get here you take alcohol as the medium, alcoholic ammonia, so that it will be RNH 2 plus X minus. But by the elimination of H plus ion, it will give you a 2 degree amine. And then this will again act as a nucleophile the third time to give you 3 degree amine. And again, you will get a 3 degree amine. So you get a mixture of one degree, 2 degree, 3 degree amine. But but you can have, if you take excess of supposing you are taking an alkyl halide CH3Cl with excess of ammonia. So after getting primary amine, there is no substrate to attack. So 1 degree product will be the major product. But you get a mixture of all products if you don't take excess of ammonia. We shall be studying in details. Of course, I forgot to tell you, there is another step. There is, supposing this is the 3 degree amine, it will attack another alkyl halide to produce a quaternary ammonium salt. I forgot to tell you, CH3 whole 4N plus Cl minus. This is a salt, quaternary ammonium salt. This is 4 degree. This is not an amine, it is ammonium salt from which you cannot get, there is no H. So elimination of HCl and getting a neutral amine is not possible. It is a salt. You have to throw it out. But in all other cases, amines can be separated. What happens really? Ultimately, they remain in the form of their salts. This is this जोटा आमे कॉले देखेले এই ফর্মে সে ultimately থাନ୍ତି এই ফর্মে থাନ୍ତି ultimately ମୁଁ ତାକୁ ଡିପ୍ରୋଟୋନେସନ କରିକିରି ସକ୍ସେସିଭ ସବଷ୍ଟିଟ୍ୟୁସନ ରିଆକ୍ସନ ଦେଖେଇଲି କିନ୍ତୁ ଅଲ୍ଟିମେଟଲି ଛାଡ଼ିଦେଲା ପରେ ସିଏ ସଲ୍ଟ ଆକାରରେ ଥିବ NH then we have to add excess of alkali NaOH and distill so that so H plus ion jaha lagikiri thila that will be delinked by OH minus and will be neutral amines 1 degree 2 degree 3 degree they will be distilled off, they are volatiles. But the 4 degree ammonium salt ଯେତିକି ହେଇଥିବ ସିଏ ଯାଇପାରିବନି, it is ionic compound, ସିଏ ରହିଗଲା ଏବଂ 1 degree 2 degree 3 degree amine ପଳେଇଲା, deprotonate completely ହେଇଗଲା ପଳେଇଲା, and then their boiling points are completely different from each other. Fractional distillation will separate 1 degree from 2 degree 3 degree. 1 degree amine has the highest degree of hydrogen bonding. There are 2 hydrogen atoms, although it is nitrogen, the strength of hydrogen bonding is poor, but still the degrees maximum is 1 degree. So boiling point of 1 degree is greater. Then intermediate is 1 degree having some little hydrogen bonding, but 3 degree don't have any hydrogen bonding. Its boiling point is the least, and we can easily separate the 3 amines from each other. So this thing we missed out today. We close our session. And maybe tomorrow is not possible because we are going away, because I told you that there will be 2 more days for me to spend time with my family. I mean my son's, elder son's family of the 2 granddaughters and their parents. So we are going away from Cuttack for some distant place, Berhampur. And therefore, there will be no class tomorrow. We'll be only meeting on Tuesday, coming Tuesday. Bye-bye.
Pranam, sir.
Thank you, sir.
Hey, ତମ doubts ଅଛି ମୋ ପାଖରେ, still pending,
Yes,
ସେମାନେ
sir.
କଲା ପରେ ମୁଁ କରିବି ଯାହାର doubts ଅଛି ମୋ ପାଖରେ pending.
Yes.